So this is October 20, 2022, paper 4. The first one, which row of the table describe the mass and the charge of antiproton? Because it's an antiparticle, so what is the difference between a particle and antiparticle? They have the same mass, but they have opposite charge. So it should have the same mass, but charge should be opposite. The charge of a proton is 1.6 exponent minus 27. So either A or B can be an answer, but it's an antiproton, so it should be negatively charged. That's why B will be the right answer. Which of the following is a valid conclusion about alpha particle scattering? Oh, this was a Rutherford experiment. He did the alpha particle scattering experiment. Atom contain positive and negative charge distributed evenly. No, the positive is in the center and even is a electron like negative charge around. The nucleus of an atom contain protons and neutrons. This is what he did not conclude. He did not say about that proton and neutrons are there inside the nucleus. He said mass is present in the specifically like his Rutherford experiment was there. So existence of a proton or neutron was not known at that time. Like he did not say anything about the proton present in the nucleus. It's just a structure of an atom. So if even that time proton and neutron were not discovered, so he cannot state that proton neutrons. The nucleus of an atom is very small as compared to size of an atom. That's right. An atom contains very no atom. Most of the atom is empty space. So C is a right answer. In question 3, which of the following describe why electrons are released from a metal filament during thermionic emission? So what actually happened? Thermionic emission means when it will absorb energy. Like a metal filament is heated by electric current. Because when a current is passing through, current produce heat energy, and that heat energy causes the electrons to move out. So A is the right answer for this. Like we're not heating it metal filament, it's like we are passing a current produce heat, and that remove the electrons out. So these are light charges. These are the fields of a light charge. Light charges repel each other. And if you compare, the field lines are closer for this one as compared to this one. So it means they are identical charges and this is stronger. Y is stronger. So y cannot be Q. It should be -2. Because if X is equals to minus Q, the Y should be equals to negative Q as well. But twice, why it is twice? Because it is producing a stronger electric field. That's why it must be twice. As we know, field lines are closer to each other. Then the graph is which of the following expression give the energy in joules, energy stored in the capacitor. So energy stored in the capacitor is half base into height, area under the graph. So it will be half Q into V. So it is half 550 nanocoulomb. So into 10 to the power -9 multiplied by the voltage, which is 12. So half 550 nanocoulomb into voltage divided by 2, because area under the graph will give us the energy stored by the capacitor. SI unit of a magnetic flux density is Tesla. Which of the following is give the base unit of Tesla? So you can use in like any formula which you can remember. F is equals to BIL is there. BIL sine theta. So B is the strength. So the base unit of the force is Newton, but base unit is kilogram, meter second raised to power -2. Then B is there. This is current is ampere and length is meter. This M will cancel with M here. So it will be kilogram second raised to power -2 divided by ampere. And this will go up. So it will be kilogram ampere inverse second -2. But it will work with any formula which you remember related to magnetic field. Which of the following could be a quark composition for a baryon with a charge +2e? But C and D are not baryons, C and D are mesons. So these are the baryons. For down, it is minus, for positive, it is +1/3. So -1/3. This will be minus 1 by 3, minus 1 by 3. So when you simplify, it will be minus 1. Here, plus 2 by 3, plus 2 by 3, and plus 2 by 3. When you simplify, it will be 6 by 3, or you can also say plus 2. So D will be the right answer. 2 by 3 E means like 2 by 3 times the charge of electron. A LINIAC is a particle accelerator. It consists of a drift tubes increasing length. Which of the following is a reason drift tube increases the length? So when a particle is moving, it should take the same time when it is moving through this LINIAC, like the. So we can apply a constant potential difference with a constant frequency. Like every time when the voltage or the potential change, will change take the same time. Like plus minus become minus plus in 2 seconds. So here also plus minus become minus plus in 2 seconds. So every tube it should take the same time interval. So we can apply a potential can have a constant frequency. So when it switch, it will receive the same potential and accelerate between the two cylindrical tubes. An object of a mass m with a momentum. Which of the following is a mass of an object with a momentum 2p and the kinetic energy? So we have the formula p square over 2m, ek, the kinetic energy, is p square over 2m. So m will be equals to p square divided by 2ke. So the momentum is double. The momentum is double, so this will be 2p square, and the kinetic energy is 4. So this will be 4p square over 2 4 ek. So this will cancel with this. 4 will cancel. So this will be p square over 2m. Like p square over 2 ek. So this is the same expression. The mass is given by p square over. So this is same as m. That's why B will be the right answer. Because if you double the momentum, like momentum is double, so the mass, it means it is 2p square, so it will become 4p. The next is two coils are there, placed next to each other, an alternative induced EMF across a coil M. Which of the following could produce this? So if there should be an AC supply, alternating current should be there in a coil L. Whenever there is a change, because if this alternating current, there will be a change in magnetic field. And change in a magnetic field induces EMF. A constant current will not produce any constant change in magnetic field. Decreasing a current, it will only, we want a continuous EMF to produce. When we decrease the current, there will be a change in magnetic field, which induce EMF for a short time. Once the current is constant, the induced EMF will be an increasing current. Again, this will produce once, but what we want alternating induced EMF across M. So we need an AC supply which produces a constant change in a magnetic field, and constant change in a magnetic field induces EMF in the secondary.